All right, part two. Now let's not lose sight of what our goal is. Remember our goal. So two problems that we're going to look at today. One is, you're going to notice that we want to be able to do summations where there is no stopping point. You know, not for right now, we just put in. So from one to something, and we put in, and there would be a reason for that. Now, again, not to lose sight of what our goal is. Our goal is to find this actual area under f of x is x squared plus 1. All right, and we've talked about at the start that we're going to use rectangles to make approximations. So, and the other thing we've talked about is to increase the number of rectangles. The more rectangles we can put under the curve, the better we're going to get to the area. So mechanically, now you're going to bump up the summation problems so that that we can handle those situations when we get to them there. So we have a summation problem similar to yesterday, except imagine if this had been a 5, this would be 25 here, right, in the denominator. If this had been 6, that would have been 36. If it was 1 to 10, we would have been dividing by 100. So your n over here, n is a constant, but we're leaving it as n, and the thinking is this. If I wanted, let's just say that this did tell me, like this was the formula for maybe the area of these rectangles. And let's say I wanted to do 4 rectangles, and I get that answer. Well, then I want to do 8 rectangles. I get that answer. And then I want to do 16 rectangles. Well, that's 3 problems. That's 3 times that I got to go through and work it. So instead of working a summation 3 times and changing the n, I'm going to work it once and get a formula with n in it, and then at the end, I sub my n's in. So the thinking is that we're going to just work it one time here. It's going to look a little crazy because you're not going to get a numerical answer, but we're going to get a formula with n, and then we can plug in, and this does represent some area, okay? All right, so let's remember our summation rules real quick. What is the rule for sum of a constant, 1 to n? What's the sum of a constant?
N times c.
N times c, all right. What's the sum of I? 1 to n. Sum of I.
N over 2, right? N
Yep.
times n plus I.
N plus 1.
Yeah.
So remember, you will sub in for your I. All right. What's the sum of, let's just leave those 2 for now. That's all we're going to need with this one. All right. So then let me, my computer's killing me, guys. All right. So let's get started with this problem here. Now, the first step, I'm going to help you. So n is a constant. Don't look at it as, so only the thing that's changing is I. So, like I said, had this been 5, this would have been 25. So the first thing I would do, this is like saying, you can picture this as 1 over n squared times 3i plus 2. So you can think of that as a factor and take that out, okay? So here's what we're going to do. Simplify this summation. So our first part, simplify the summation so we're only in terms of n. Then evaluate you'll have a formula within it for any is 10, 100, and 1,000, okay? So those are the two steps that we're gonna do there. So your first step is just bring this 1 over n squared out because it's a factor, and then go and simplify this as much as you can. You're trying to only have n's, no more I, all right? So work this out as much as you can using the tricks that I taught you yesterday. You only should have n's, no summation symbols. Okay, since we got the ones at home working along with us, let's go ahead and get started. Well, what's my first step with this? Split it into two. All right, so we split it into two. As I split it, I'll put brackets so that that 1 over n squared goes to both. All right. Then what should I do?
Pull out the 3.
The 3, yeah. So on this one, you gotta bring the 3 in front so that it matches these rules exactly. And now you just make your substitutions. So once you get to this point, now you're just following what the rule says. What's the sum of I as I goes from 1 to n? That, n times n plus 1 over 2. You replace it with n's, okay? So that, this here I can sub in, and this one I can sub in because I have the sum of a constant. So we get 1 over n squared bracket 3 times n over 2 times n plus 1 plus 2n. And now you have a formula with just n in it. Now all you gotta do is plug in what you want for n, and that should give you some area of some region. We don't know what the region is, okay? So this represents it. So like, I don't know what for this problem, our region could be something like this. And n is, n is how many rectangles did we fit to it? So n is the number of rectangles. That's what n stands for. You'll see that as we work on. Now, I might clean this up a little bit. So I might do this. So let's see. I might get a common denominator of 2 here. All right, and I could make this 1 over n squared times 3n times n plus 1 plus 4n all over 2. Could do that. And then if I distribute this 3n, my numerator becomes 3n squared plus 3n plus 4n. So if I distribute the 3n, I get 3n squared plus 3n and plus the 4n. So I could write this as 1 over n squared, 3n squared plus 7n over 2. And now last step, just bring the 1 over n squared back in, and I get 3n squared plus 7n over 2n squared. And now you have a much more efficient formula to work with, to plug in, rather than this. So there's some algebra involved in simplifying. And this probably represents the area for n rectangles. Now, we can do however many rectangles we want. So now what we're going to do is plug in. So if this is the area for n rectangles, you pick how many rectangles you want to put, and let's see if we start getting close to an answer. So you can do a of 10, a of 100, and a of 1,000, and let's see if we start getting close to a particular value for the area. So 10 rectangles, 100, and we talked about this, the more rectangles we put, the better it should fit to the region. I don't know what the region is, I just made something up. You know, maybe this is my region here. And we're trying to find the area of it, okay? So plug in your 10, 100,000, use your calculator. Let's see if we do converge to a value. If we do, we get closer and closer to a value. All right, what do you get for 10?
I have 3.07. Or do you want one?
Yeah, give me more decimals.
I probably messed up. That's all this one's like on.
That's it? No, you didn't. I know it's close to, I don't think that's right.
307.
307 divided by 200. No, 370. 370 divided by 200. See? Plug in a 10. That's 300. That's 70. 370 over 200. What do you get? 1.85. All right, there's that. Okay. What happens when you put in 100? That's right. All right. What happens when you put in 1,000?
1.5035.
Okay. Now, does it look like we're starting to get closer to a value? What does it look like we're approaching?
About
1.5. Now, so again, this means that whatever our region is, let's just say this is our region. We're trying to find the area of some region. And this whole thing right here, this represents the in rectangles. This represents the area, okay? So like we're gonna make, you'll see we'll make area formulas, but we won't just do 4 rectangles, we'll leave it as in. think, 1,000 rectangles in here. It should be pretty close. What would be perfect? Yes, that's exactly right. So how you get the exact area, you take the limit as n approaches infinity of 3n squared plus 7n over 2n squared. And if you remember, we had rules. If the degree of the top and the degree of the bottom were the same, you just take the leading coefficients, and our answer to this problem would be what? 3/2. That would be the area. Okay? So you're going to do one more like this. So I call this example 1. This is me helping you through one, and then now you're going to do it on your own. Same technique. But now the formulas may be a little bit, you may have to use I squared. You may have to use something else, okay? So we'll do another one here in a second. But yeah, that's what, and if you're going to do 10, 100,000, and then let it go to infinity. But see, 3/2 is the decimal, 1.5, which is what we were approaching. It should converge to a value. It should get closer to a value, okay? And then once you go to infinity, you can find that value. All right, so I'm gonna need to erase this because this is very jumbled, okay? Is everybody good to, all right. So let's do one just like this one. Again, it represents, it should represent the area. I mean, I'm hoping it does. And then, you do 10, 100,000, and then you do all right, so we'll just do another one here. So given the sum, and it won't always be I, it could be, in this case, it could be a K or something. So here, K goes from 1 to N, 6K times K minus 1 over N cubed. Now, if you don't like the K, change the K to a what? An I. It's your counter, okay? So if you don't like the counter K, you can make it I and replace those with I's. So the first thing, so given this represents, remember this represents the area with n rectangles. So you just have n rectangles. You don't have a, we're leaving it as a varying quantity so we can plug in. Then we're gonna simplify, so part A, simplify the expression so that it's only in terms of n. Then we're gonna find A of 10, A of 100, A of 1,000, and then eventually, I know this is taboo, but I'm putting A of infinity, means what you said was exactly right. Take the limit as n goes to infinity. Okay, go ahead. So you guys at home, this probably the video is just gonna run here for a little bit. You might wanna fast forward about 5 minutes. And then we'll go from there. I wish I could pause, but this thing doesn't pause. Or just let the video run and work along with us. gotta be careful with this one. You have a multiplication in there. You can only break up summations with addition and subtraction. Remember, you can take factors out. Multiplying factors you can take out if it's constants. All right, so I'm gonna start catching up to you a little bit. So the first thing I would do is this 6 over n cubed, I would take out, okay? So I'll bring it to the front, 6 over n cubed, and then I don't want multiplication in there, I want addition or subtraction. I'll just distribute this k, and then get k squared minus k. K is the same as my I, okay? And so now all I've got to do is break it up into two summations, and then I'm ready to substitute my formulas in. K goes from 1 to n of k squared, minus the sum as k goes from 1 to n k. Same formula as with your I. So now you got to look back. Well, what was the sum of I squared? 1 to n. So then I'm going to make those substitutions. So each summation has a substitution. So 6 over n cubed. Let's see. The first summation becomes n times n plus 1 times 2n plus 1 over 6, if you remember that, minus the sum of k, which is n times n plus 1 all over 2. So technically I'm done at this point. I have my formula with n in it, because it did. It says simplify the expression so that it's only in terms of n. That's this. However, I like to clean it up a little bit more so that I can let n go to infinity. So what I typically do is I'll make it one fraction. So I'll get a common denominator here. You don't have to expand this. You can leave it like this. And then I'll distribute this 6 over n cubed. So I'll at least get a common denominator, but you don't have to expand it, because that's a lot of multiplying there. And I'll show you how you can get an idea of what the answer is going to be. All right, so just going to do a common denominator of 3. So I'll put, or of 6. So I'll put my 3 over 3 there. So if we just continuation here, 6 over n cubed, bracket, n times n plus 1 times 2n plus 1 minus 3n times n plus 1 all over 6. And now, if I bring my 6 over n cubed in, if I actually multiply this, what happens to these 6's? They're going to cancel, and the n cubed comes in. So now I can cancel the 6's, and I'm just going to slide my n cubed underneath. And this is my area of n rectangles. I'm choosing not to expand the top because I'm trying to save time, and I'm just going to plug my n in there. Maybe it makes a little bit more work for you, but I'll show you when we get to where we have to do the limit, how I can think through and know what the limit is. So I'm going to save time and not expand it. Okay? All right, there you go. There's your formula. So this should represent some area with n rectangles. Now you're going to plug in 10, 100,000. So find each of those, and then we'll get those answers. So I'll just store them over here. So get a of 10, a of 100, and a of 1,000. And let's see if we start to converge to a number. But you can see when you plug in, it's going to be 10, 11, 21, 30, 11. You know, all over 10 cubed. So do like you did last time. Everybody does it so that way if we make an error, I'll use this all like this for you, okay? Just so you can. I'll leave that there. Want the white. Okay. So let's all double check our answers or computations. You should get something close to 2. 2 should be the ballpark that you're in. Anybody have their first answer? 10, 11, 21. 10 times 11 times 21 minus 30 times 11. That's what I got on the top. Now you plug in a 10. All right, anybody have A of 10? What do we have? 1.98, okay. That's actually pretty good. If I said 2 was the, anybody have A of 100? 1.9998. So I think we got an idea of what our actual area is. You can see at 10 rectangles, you almost got a perfect fit there. All right, what did you get for 1,000? 99998. All right, so at this point, you've got the, you know what the limit is going to be, but we'll just go ahead and do the work. So limit as n approaches infinity of this. Now, remember, you're only looking for the highest degree in the top and the highest degree in the bottom. So I'll show you how I kind of cheat through this and do this here, okay? So here's what I do. I knew if I multiplied the top out, that the highest would be when this n times this n times this 2n multiplied. See, so in the numerator, guys, everybody look here real quick, because I'm going to save you time when you're doing these. I'm not going to expand the whole thing. I know the highest degree here is going to be n times 2n, which is 2n cubed. The highest degree here is just 3n squared, so that is negligible. So I have a 2n cubed on top over an n cubed on bottom, and there you go. It's 2 over 1, which is 2. Everybody see how I got 2n cubed? I don't need the other little parts. Remember the negligible that we only take the highest degree coefficient, okay? And there you go. All right. So the question for us is going to be, how do we get this? Right, because that's what we're going to have to come up with when we're trying to find the exact area. So now we're going to so now you have all the tools to find area. In terms of the mechanics that's going to be needed to write these sums. We don't know how we're going to write these sums just yet. Now we're going to kind of go back and just go back to, okay, let's go to these problems here. Let's just take one like this. You're going to get a couple of different graphs, and you'll have 4 rectangles, no more than 4 or 5 rectangles. And now we won't worry about writing a formula. We'll just find the area of those 4 rectangles. So that we go back to, okay, now what's the idea we're going to build on? So we're kind of deconstructing what we've been doing and going back to just a simple, using simple geometry to do this, okay? So is it okay if I erase this? It's all going to be in the video. Oh, my 2 almost got cut off down there. Let's make it in. Okay, so we'll erase this. So we put evaluating sums for n. Now, the book uses the terminology upper sum and lower sum. I like to use the terminology left sum and right sum. All right, so we'll explain each of them. They're both the same problem, okay? Except your upper and lower keep switching. So here we have this graph of square root of x from 0 to 1, okay? And what we're going to do, the question is going to be posed like this. Part A, find the upper sum for 4 rectangles. Now, I would not have used the word upper, I would have used right sum. but they want the overestimate. They want the one that's gonna be an overestimate. So, first thing is this, is I have to break up, I have to see, okay, my total width of the interval goes from 0 to 1. So the first thing I always wanna know is how wide is each rectangle gonna be? So let me ask you this, how wide will each rectangle be if I have to put 4 rectangles from 0 to 1? 1/4. Now, there's a way to find that. So the width of each rectangle, I'm gonna now refer to as delta x. And delta x, because I think it's a change in x, and delta x is always b minus a over n. B and a are the endpoints of your interval. So if you have an interval that goes from A to B, you want to know what's the width of each rectangle, you just take the width of the interval and divide by how many rectangles you're going to do. So 1 minus 0 over 4, exactly, it's 1/4. But the reason I'm saying this is, what if I have to go to pi, or pi over 2? Like 0 to pi over 2, and I got to put 8 rectangles. It could be, so you want to follow this when you need it, if you can't do it in your head. So upper sum, so there's 2 ways that our rectangle is going to go. So now we know where our 4 subdivisions occur, right? At 1/4, 2/4, 3/4, and 4/4. Now I do it like this. And then I go and simplify my fraction because I know that my incrementation is 1/4. So this is 1/4. See, right here, 2 1/4, 3 1/4, 4/4. Okay? All right, now, if it says an upper sum, so I got 2 ways when I go to draw my rectangles. Let's just go to this second part here. Either the left corner of the rectangle will touch or the right corner of the rectangle will touch, not both. So either my rectangle is going to go like this, or my rectangle is going to go like this. Now you can see why I like to use the word right and left. Now you've got to figure out, well, what does upper mean? Upper means which corner? Right, because it goes above the graph and it's going to give you an overestimate. So upper means a big sum. It's going to be too large. It's going to be larger than the actual area. So you're going to have to know, when this is upper, you're going to have to test. Should my left corner touch? I'm blocking this, sorry. Should my left corner touch or should my right corner touch? So since the word upper, I want my rectangle to go above the graph, okay? I think this is poor terminology because sometimes the graph can change. It can be over and under. It's hard to tell. So I like using the corner. I will ask you right sum for this one. All right. So that means that my right corner will touch, and then I go and make my rectangle. All right. You don't have to draw the rectangles. A lot of them they're drawn for you. All right. There's that. Now, so all you've got to do is find the area of those 4 rectangles. That's it. Now, here's how I like to do it. If I know I'm going to have 4 rectangles, I'm going to have 1 area, 2 area, 3 area, 4 areas that I'm going to add together, right? So I'm going to have 4 areas that I'm going to add together. Each rectangle should have the same what? What do they have that's the same? The width. So we already know the width. 1/4, 1/4, 1/4, 1/4. So I know that the width is going to be the same for each one. Now, I need the height of it, but I'm gonna go ahead and write it in notation. See, so for instance, this first rectangle here, I need the height of this rectangle. Well, that's this. Well, what is that? Well, notice, it touches the curve. So this height is the y value when x is 1/4. So how do you say y value when x is 1/4 when you have f of x? F of 1/4. So we're going to say 1/4, f of 1/4 for the first one. because that's the part that touches. On the second rectangle, 1/4 times f of what? 2/4, or you can make it 1/2 if you want. I just did that so you can see it. So you can make it f of 1/2. And you're gonna need your calculator because you can't do square root of a half and get a nice answer, okay? All right, then the next one, 1/4 times f of 3/4. And then the last one's 1/4 times f of 1. And you know your f of x is square root of x, all right? So go through, you're gonna plug these in, you're gonna get your values and see what you get for your area for 4 rectangles, okay? Now, you could make your work simpler if you wanted to factor out a fourth and then add all those up, f of 1/4 plus f of a half plus f of 3/4 plus f of 1. You could do it like this because each term has a 1/4 in it. I don't care. Let's just make sure we all get the same answer. It should be something less than 1. If it's a number bigger than 1, then you've made a mistake. And in calculus, AP exam, they'll ask you to round to 3 decimals typically. If you want to round to 3 decimals, that would be good. I think the more is better, so we can always take it and round it from there. It should be an answer less than 1. If you have an answer bigger than 1, we have an issue. It should be between 0 and 1, and then you're going to tell me how I know that. We want to shout out an answer when they have it, and we can check from there. Just give us like 3 or 4 decimals. What do you have? No, the end. Yeah, I don't need to know all that. 0.0?
Yeah.
That can't be right. It could be 0.814, but not 0.0814. Check your work. 0.768, anybody else?
I got 0.552.
It could be that. All right, so let's just go through. What did you get for f of, look, f of 1/4 is 0.5. Right? Because it's the square root of a fourth, is that you should be plugging these into square root. So square root of 1/4 is 1/2. That's 0.5 right there. Plus f of 1/2, that's square root of 1/2, I don't know. Plus f of 3/4, that's square root of 3/4. Make sure you're doing your square root and you put your fraction in there. The last one, square root of 1 is 1. So, and then I know it's at least 1.5 plus these two things divided by, or multiplied. So you're gonna add all that up and then multiply by 0.25. You wanna try again? I mean, I don't know, the 0.768 sounds good, the 0.5, but I know it's not 0.08, that's not enough. What did you get this time? I wish you guys at home could yell to us and tell us your answer. Ivan, what about you? Okay. I would just type it in just like this. I would have just done square root, open parentheses, 1 divided by 4, plus square root, open parentheses, 1 divided by 2, plus square root, open parentheses, 1 divided by, 3 divided by 4, plus square root, 1. Get that answer. Then say times 0.25, done. Type it in like that, I give you the answer. What do you
I
got?
got, oh wait, you got 0.768.
0.768, well done. That sounds right. Okay? All right, now, let's talk about a couple of things. How did I know the answer was less than 1? How do I know 1 was the ballpark? One by 1 has to fit into this big green space. 1 by 1 rectangle, it's gotta be less than 1. Okay, all right, so you're just gonna have to work on how you input. I'm gonna go ahead and say 2 of you got 0.768. Ivan, did you get it? Pull up what you typed in. Second enter. Just hit second enter. All right, read it. All right. Hit enter. Fine. Go ahead to 0.25. Take your phone out of your lap. Don't have your phone in your lap in the middle of calculus class. Now you have 0.768. Here's your answer. 1/4 is 0.25. All right, got it? Next. What are we gonna do now? What do you think? Left sum, which is now gonna be a lower sum. So we're gonna do left, so look at the green rectangle. So look at the first one. What do you notice about my rectangle? If I do the left corner, it touches the curve. Zero, that one's gonna be 0. Then the next rectangle is gonna be here. Okay? Then the next one's gonna be here. And the next one is here. Okay? And here are your 4, actually just 3 rectangles. So don't even do the first one. It's 0. And you can see f of 1/4, f of 1/2, f of 3/4. The left corner touches. So on this, you can write it out, but why waste your time? It's 0. So the width of all 3 of these is 1. So I'm going to do my left sum now, and I'm going to say 1/4 times, and I can see which where it is. It's the heights are f of. Everybody see where I'm getting f of 1/4, f of 1/2, and f of 3/4. So now you can go back to what you just did. Hit second enter, brings it back up. Delete whichever ones you don't need in there. I think it's just the f of 1, and then multiply by 0.25, you should get the answer. Once you've typed it in, it should be fairly easy. So let me erase these blue ones so you can see the green ones. These are all left sums, because the left corner is touching the curve. See, no rectangle, 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 rectangle. You're gonna, they'll have these drawn out for you in the homework. You should get something bigger than 0.768 or less than 0.768. Less. Here's your lower sum. What did you get?
I got 0.518.
All right, good. So now, what do we know about the actual area? Okay. Now that's later. How do we get the actual area? That's later. So they're going to give you different curves. You're going to look for these type of problems. You'll see it'll have a graph. It'll have a graph like this, and it'll have both drawn. It'll have the lower rectangles and the upper rectangles. And those you should be able to do. And then these problems you should be able to do, okay? All right, I'm going to stop it there. So we're going. Green doesn't show.